Well, hello again. Welcome back to part 3 for our thermal energy unit. And in this part, I'm going to focus on something that you can probably relate to pretty well, and that's how you heat your home or wherever it is you live. And I'm going to describe 4 of the most common ways that homes are heated. And you may have some system that's a little different than some of these, but most of you will be able to recognize some of the features in this in wherever you live. And so one thing I'd like you to be able to do when you're done is to identify which system you have wherever you live, and then you can kind of see around the house the different parts. So I'm going to start with probably what most of you have in your home, and that's called a gas forced air furnace. And so you'll typically just call this the furnace. Now, I'm not going to write everything the way I do sometimes with the notes, but I've left you some lines here next to the diagrams so that you can make some notes about the important features, things to look at. Some of the diagrams are a little small, and so I'm going to go to a bigger version for you to see on your screen, and then you can jot on your paper some of the things as I'm describing it. So, in a gas forced air system, now let's take a look at the bigger picture. The key part of the system, what we call the furnace, just looks like a big box, right? And it's typically going to be in a basement, could be in an attic, could be in a closet if you don't have a basement or an attic. And you'll know it's a furnace, a gas furnace, because there will be a gas pipe going to it. Now, it's not shown here. The gas pipes can look differently. And you'll also recognize that when it's on, there's a big flame somewhere that usually you can see. There's a little window and you can see the flame. You can also hear the flame going if you're up close to it. So the idea of the gas forced air furnace is that we have this flame, and what we're doing is we're just heating up an area of the furnace, and then we force air to go over that, what we call a heat exchanger. And as the air moves across there, it picks up the thermal energy from the flames, and then the air itself is much warmer. And then it goes out through what we call a system of ducts. We call these supply ducts because we're supplying the rooms in the house with the hot air. So you'll see then in each room, sometimes more than one in a room, what we call the heat register, a supply register. In a lot of houses, these will be on the floor, and you'll know what those are because you can feel the hot air being blown out of there when the furnace is going. In some newer homes, they tend to put them on the ceiling because people don't like them to be in the way of their furniture. They could be in the wall, and those aren't very efficient when they're on the ceiling because heat tends to rise anyway. And so when you're blowing the hot air out, it has a tendency to stay up near the ceiling. So you can use things like small ceiling fans to blow it around, but mostly the movement of the air and the energy is provided by a fan that's inside the furnace. Okay, so a big motor turns a big fan, and that's why we call it a forced air, because the fan is forcing the air through it. And then it goes out into the room and should distribute itself pretty nicely throughout the room. And then the air has to go back to the furnace and be warmed up again. And so you'll also have in every room, or maybe there's just a few throughout the house. In newer houses, they tend to be a lot more open, and so you might have one spot in the kind of in the middle of the house with a big vent, and that's the air inlet. Now, sometimes it's hard to tell where the air is coming out and where it's going in, but if you go and just kind of feel when the furnace is on and feel, do you feel air coming out? Or if you take something like a little tissue and put it up close to the air return, you will actually see the tissue being sucked in towards the vent. And that's how you know it's the return. And so on this diagram here, if you see the return, it goes back, and then the air goes back up over the flame again, and the whole process recycles. And so this is just recycling the air that's in your house. Again, in a newer, fancier system, you might bring some fresh air in from outside, but usually it's just the air being recirculated throughout the house and being heated up each time it goes through the furnace. You'll also recognize, in addition to the gas line that's going into the furnace to supply the gas to burn, you also have a flue. That means after you burn the fuel, you have to have a way to exhaust the, the emissions and that's out the wall or up through a chimney. In most older homes, you're going to see a pipe, maybe a metal pipe going up towards the chimney, and then it goes up and out through the chimney above the roof. So that's all the basic parts of every gas forced air furnace. There are some electric furnaces as well, so everything is the same, except if you live in a neighborhood where they have not run natural gas through the ground, and so you can't get it to your house, then you have to have a different source of heat, and that ends up being what we call electric resistive heat, which is basically like you get in a toaster. You just run electricity through some wires. The wires get really hot. They usually start to glow, and then you extract the heat from those as you pass the air over them. So that's the basic function of a gas forced air furnace, or its close relative, which is the electric forced air furnace. So maybe stop here and make some notes about what you heard and what you saw. You can label your diagram a little bit better because it's a little blurry on your page, and then maybe continue the video and we'll go on to the next one. Okay, the next heating system is known as a steam radiator or steam radiant heat. And this system is more likely to be in older homes. I'd say maybe back in 1930s, 1940s is when they started to get away from this. So if you've got an older home, or maybe one of your relatives does, you may have seen things like this. I've got a picture on your page there of what a radiator looks like. These are typically in every room, often including the bathroom, and I mean, you'll know that's the source of heat because those things get really hot. A lot of times you can't even be too close to them because they're so hot. You can't put furniture or drapes near them. A lot of times they were close to windows because windows were an area that would get really cold because they didn't have good insulated windows back then, so they wanted to heat up that area there. And I've got a better diagram here that I've kind of blown up, and you can see the main parts. Again, kind of write down some of the important points as I go through it. But what you see in each room is this radiator, and often what you don't see down in the basement or something is the boiler. So the idea of the boiler is we burn something like gas, or back in the old days they would burn coal, and they would just make a big flame and warm up the water to the point where it was steam. And then the hot steam rises through pipes, and then those pipes go up into every room in the house that has one of these radiators. And then as it goes up and cycles through the different parts of the radiator, that heat is given off into the cooler air in the room. It causes the steam to lose its energy and then condense back into water, where it can just drain. You see how they slope it, so the water runs right past the steam that's coming the other way and drains back into the tank, only to be reboiled again into steam, and so the cycle continues. So this happened in every room. And then because the heat was always here by the heat registers or the radiators, the question is, how do you get the rest of the room or the rest of the house to be warm? And this relies on convection. So remember that warm air tends to be less dense, and less dense things tend to rise. And so this hot air would rise up to the room, and the air that was up near the ceiling then would be pushed down closer to the floor and closer to the radiator, and then it would be warmed up, and then it would rise up again, replacing cooler air up there, and the cooler air would come down, and so we get what we call convection currents throughout the room. And in theory this would warm up the entire room, but sometimes you didn't have the best convection currents through your room, and so you could get some hot spots and some cold spots, and there are all kinds of ways to kind of supplement that. But still, it's a pretty good system for without forcing the heat anywhere, just to rely on nature and convection currents to carry them around. So again, there's some variations on this, and it's very likely you could be in a house sometime. If you see these radiators, go around and find where the boiler is and look at some of the other parts and see what you recognize. There's some safety mechanisms on here, like little vents and safety valves and stuff like that, that I'm not going to get into because it's not really critical for understanding how the steam system works. There are other versions of this too, but this is a pretty common one if you have steam heat. So again, maybe stop it here, finish making some notes, and then we'll continue on with the third type, which is the radiant electric baseboards. Okay, so I'm back. You can tell that I'm in a little different place. It sounds a little different. There's a different background behind me, but I'm going to continue on, and I probably won't be showing the page that you have in front of you, but I will refer to the picture there. But the important stuff to see is just on your screen right now. So the third type of heating that I'm going to describe is called electric baseboard heating. And this is probably not very common for you to have as your main source of heat in your house, but it's often used as like an extra or a supplemental form. Like if you have a room that's just a little cold, you can have radiant heat. We sometimes call them space heaters. So if they're the main source of heat in the house, they're typically in every room, and they're kind of nice looking, and they're against the baseboard, which is where the floor meets the wall. And you might have a thermostat in the room to be able to turn it on and off. And to describe how this works, and you can just write down some of these key ideas, I want you to just think about a toaster. You know, when you plug in the toaster and you turn it on, then there's wires in there that get hot when you run electricity through them. We call it resistive heating because when you try to run electricity through something that it doesn't easily want to go through, like it would easily go through aluminum wires or copper wires, but those heating elements are made of things that don't exactly want to flow electricity. And so the electricity, the electrons fight their way through there, and as they fight their way through there, they generate a lot of electrical friction, and that just heats up the wires. So just like the wires in the toaster gets nice and warm and they start to glow, the same thing happens with resistive heating in the room. You might not see it glow, but it certainly gets warm. And then what happens from there is convection takes over. Just like what happened with the radiant steam heating, the warm air down low to the ground starts to rise up, and it causes the air at the top of the room to be pushed back down closer to the heater, and then it gets pulled in across the heating elements and gets warmed up, and those sort of circular convection currents just continue to happen. Okay, so that's the main idea behind electric baseboard heat. And if you have a space heater, it's very similar, but it might be one that you can just plug into a wall, maybe move around, and put it maybe near the bed. But I do want to caution you, if you have this kind of heat, of what can happen. I'm going to show you a picture. And here is somebody who has electric baseboard heat under a window, which is a pretty common place to see it. But if you have long drapes that hang down, you see how they can get singed. And they're awfully lucky that this didn't start a fire. That's one of the more common ways for fires to start, is for some piece of cloth that even could be like bedding, like a bedspread or sheet, that gets thrown over top of a space heater. And that's a surefire way to, no pun intended there, to start a fire. So always keep any kind of flammable material away from electric radiant heat. Okay, the last type we're going to look at is geothermal. So we'll take a break here, and I'll show you how that's done. So the geothermal heating system, there's a little difference here in the way I'm kind of describing this, and that is geothermal does not describe the way that energy or heat is distributed through a house. It describes where the energy comes from to begin with. So this could actually be connected to like a typical forced air system. It could be connected with maybe some what they call hydronic heating, which is like if you have water, tubes of water flowing just under a tile or wood floor or even carpet, you can heat a room that way. But this is all about where the energy comes from. And you are not going to be using electricity. You're not going to be using gas to make a flame. All of the energy comes from the earth right below you. Because the ground temperature, when you dig down several feet into the ground and below, that ground temperature is maintained at roughly somewhere in the 50s, maybe 55 or so degrees Fahrenheit. So when it's really cold outside in the winter, maybe it's 20 degrees someday, that ground is actually pretty warm compared to what the air would be. So if we can take some of that energy from the ground and pull it into the house, then we could distribute it to the different parts of the house. And that's exactly what we see here during the cold season. So we just have fluid running through tubes. It's sort of like an antifreeze. It's not water because that would turn into ice, but an antifreeze that won't freeze up. And then we run it through these tubes that go deep into the ground, and they can go vertically into the ground. Like if you have a small yard and you don't have a lot of space, you just drill way, way down vertically. And as these tubes of fluid go down in there, into the warm ground, they extract some of the thermal energy that's in the ground. They warm up, and then it comes on back up and into the house. And then there's what we call a heat exchanger inside the house, where that energy maybe is used to warm up a big tank of water that we can run through the floors to warm up the floors. Or maybe we use it in a heat exchanger and we blow it through, kind of like we do a forced air system. But the key is that the energy is coming straight from the ground. But what happens in the warm months, like in the summer, 55 degrees actually would feel really comfortable compared to maybe the 80 or 90 degree air that would be outside in the summer. So we just do the same thing, but this time, as we send warm fluid down into the cooler ground, then it gives the heat back to the ground. And then as that fluid comes back up, it's a little cooler than when it left, and we can run that basically the same way we run an air conditioner. But all we need is a little bit of electricity to run the pump that runs this fluid, and then maybe a fan to distribute it through the air, but we do not have to actually pay for the energy that we're extracting, either extracting from the ground in the winter or expelling into the ground in the summer. So we call that geothermal. Geo meaning earth, and thermal, of course, related to heat. So that's a little difference there. So that's it for our 4 types. And there are other, again, there are special types, maybe a little bit outside the box, but the 4 that I described here are kind of the main ways that most of your homes will be heated. So take a look around, maybe at your house, and look for different signs of which kind of heat system you have. You might need to go into a attic or a basement or possibly a closet to see it. Do you see gas pipes? Do you see things plugged in? And of course, talk to the boss at home to find out, because they probably would know which type of heating system they're operating. Okay. All right. So that's going to be it for now. So finish up your notes as best you can, and then we're moving on. Thanks for watching.